Potential can be defined as a sequence properties of action potential. Threshold stimulus. It is the minimum intensity of stimulating current that after acting for a given duration will just produce an action potential. The relationship between strength and duration of stimulus has been studied by varying the duration of stimulus and finding out the threshold strength of each duration. Rheobase and Chronaxi. The weakest current strength which can excite a tissue is, if allowed to flow through it and uh, for an adequate time, is called as rheobase. The time for which it is applied is called as utilization time. The length of the time for which the current of twice rheobase intensity must be applied to produce a response is called as Chronaxi. Okay, so this diagram shows the relation between the duration which is required for the excitation and the strength of the stimuli. Okay, and we need the lowest strength of stimuli that is required for the excitation of the tissue is called as rheobase, and the time required for this is called as utilization time. And if you are using the rheobase, that is the twice the time required for excitation of the tissue, and the time required when you use 2 rheobase, it is called as Chronaxi, and it is the parameter is used to assess the excitability of the any tissue. It has all or none response as well. The action potential is an all or none response to stimuli. That is, if stimulus is subthreshold, not adequate, no action potential is produced. Once threshold is reached, a full-fledged action potential is produced. Further increase in the intensity of stimulus produces no increment in the height of action potential, provided the other experimental conditions remains same. Accommodation. It is an excitable cell is applied with a constant strength of current. The site of membrane under stimulation fails to produce action potential, that is, the membrane adapts to the applied stimulus. This is due to the slower opening and delayed closing of the voltage gated potassium channels. Conductivity. The action potential developed at one location on the excitable cell acts as a stimulus for the production of action potential in the adjacent region of the membrane. The excitation impulse is conducted along the cell membrane as a way of depolarization. This is another property of the action potential. Refractory period. If two successive stimuli for more than the threshold intensity are applied to an excitable cell, it is found that for some time after the first stimulus, the cell becomes refractory. There are two types of refractory period, that is absolute refractory period and relative refractory period. Absolute refractory period begins from the time of the firing level is reached till the repolarization is approximately 1/3 complete. During this period, no strong stimulus can initiate fresh impulse. And relative refractory period begins at the end of absolute refractory period to the start of after depolarization, and during this stimuli stronger than the normal stimulus can cause excitation. So this is diagram showing the refractory period, that is the absolute refractory period, and the relative refractory period. And the absolute refractory period is till the 1/3 of the repolarization, and the relative refractory period will be after the 1/3 of the repolarization, where during absolute refractory period the second stimulus will not produce any stimuli whatever the strength of the stimuli, but in relative refractory period the higher strength of stimuli sometimes